are word problems that talk about equal groups. And when we talk about equal groups, we're thinking about this pattern. You can write this down. The number in each group times the number of groups equals some sort of a total. Okay, this is the pattern that you're looking for. Now, I will warn you, as I probably have before, just because it's a multiplication pattern problem doesn't mean you'll always use multiplication to solve it. Keep that in the back of mind. Sometimes yes, sometimes no. Here is an example. There are 4 classes of 5th graders. I'll move in a second. There are 4 classes of 5th graders with 30 in each class. With 30 in each class. How many 5th graders are there? How many 5th graders are there? Give you a chance to finish writing all that stuff, then we'll talk about it. Now, when you get to these problems, the key to figuring this out, and again, I don't care so much about the answers, I do how you get the process of finding the answer. We're looking at, this is talking about groups, and you have to, in this problem here, figure out what word, not always do they say the word groups, it's not that obvious, but you need to figure out the noun, you guys know what nouns are. You need to figure out the noun that is a group of something. Well, for example, is a 5th grader a group of something? Like, is you one person a group of something? Is a class a group of something? Which one? Class is a group of 5th graders. So if you're doing this, okay, you'd have to say the class, we're talking about class is a group of 5th graders. So in this pattern here, it would be the number of 5th graders in each class times the number of classes equals the total. And we have to see which of those. Do we know how many 5th graders are in each class?
40, 30.
It says 30, so that would be the number that goes up there. Do we know how many classes there are?
4.
4 of them. And then you multiply how many total 5th graders are there? 120. Which I know you could have done pretty easily without all of that, but if you think about this for the simpler ones, you're going to be able to do the harder ones. Now, let's do another one that's a little bit more difficult. How about this one? Bob raked leaves and filled 28 bags. Bob filled 28 bags of leaves. On each trip, he took 4 bags. On each trip, he took 4 bags. To the car, to the truck. To the truck. The question is, how many trips did he make? How many trips did he make? Again, here is the key, and it's not always as obvious, is to figure out what word stands for groups. Now, initially, your first response is you think, well, a bag is a group of leaves. Well, we're not talking about how many leaves he took. Okay, that's not part of the problem, so that's not it. What other word in there would be a group of something? Look at the word. Is Bob a group of something? No, he's not. Bob is a singular person, not meaning anything.
Bags.
I already talked about bag. I said bag wasn't. Because a bag is a group of leaves, but we're not talking about leaves. Wade says, what is, a trip is what? A group of,
Something.
what is it though? What are we grouping in the trip? Every trip he takes.
One bag.
So a trip is a group of taking 4 bags. So if you put that in there, how many bags in each trip? Number of bags in each trip would be how many? 4 times how many trips did he make?
28.
No, we don't know. That was the question. How many trips? We don't know. That's our unknown letter. We should probably put the letter T to stand for trips. And then how many total bags did he have?
28.
28. So here's the pattern of that problem. 4 times what number gives you 28? So in this case, even though it's a multiplication problem and a group problem, you actually have to do division to find out. 28 divided by 4 is how many trips?
7 trips.
Trips equals 7 trips. So you have to think just a little bit about what each thing is talking about. Yeah, that's probably good enough. I'm sure you'll figure it out. You're a smart